Here are the sample problems for Class 7 of Math 117. The first two concern Acme Corporation, from which you may know Wile E. Coyote buys dynamite and various other stuff to use against his adversary, the Roadrunner. And what we're told about Acme Corporation shares is that 3 years from now, either Acme will do well and they're worth $48, or Acme will do badly and they're worth $16. And today we are told they're fairly priced at $20. The interest rate 6% over 3 years, 0.06 times 3 is 0.18, and a nice approximate value is e to the 0.18 is equal to 6/5. So you could put your money in the bank and it would grow by a factor of 6/5. And we use that information to calculate the fair price. We say the probability that it goes up is P, and let's look at the amount that you will collect 3 years from now. If it goes up, you collect P times 48. If it goes down, which happens with probability 1 minus P, you collect 16. And the expectation from owning this share should be the same amount as if you put your money in the bank, in which case your $20 would grow by a factor of 6/5 and come out to be $24. This is a bit of elementary algebra now. 32p plus 16 equals 24, and therefore 32p is equal to 8, and we conclude that the probability that the shares are going to go up is 1/4. That's enough information to figure out the fair price of an option. And we have an option with a strike price of $24. That is, this option gives you the right to buy a share of Acme for $24 3 years from now. Let's figure out how much it's worth. If Acme shares go up, your option is worth 48 minus 24, or $24. So the expected amount you collect is 1/4, the probability of it's going up, times 24, or $6. But you get this after 3 years. Today's value is $6 divided by 6/5, or $5, because you could take your $5 and instead of buying an option with it, just put it in a bank and it will grow to $6. Now, there are 3 things you can do with your $20. If you put it in the bank, $20 grows to $24. The profit is $4. Or you can use your $20 and buy 1 share. If the shares go up, you're going to gain $28 with a probability of 1/4. Or the shares might go down. You lose $4 with a probability of 3/4. And what do you know? 1/4 times 28 minus 3/4 times 3/4 probability of losing $4. That's 7 minus 3. So your expected profit is $4. Exactly the same. Or you can take your $20 and buy 4 options at $5 each. If the option is in the money, you're going to receive a tidy amount. You will make a profit of 24 after exercising the option for each, or you will collect a total of $96. Otherwise, you receive nothing. So your expected profit is 1/4 times 96, but you paid out $20 for the options, so that's 24 minus 20, or $4. In other words, your expectation is the same whether you put the money in the bank, invest in Acme shares, or invest in Acme options. In the real world, of course, people expect to be compensated for a higher risk with a higher expected profit. But this is a math course, we'll ignore that. Now let's take a different view of the situation where we never actually compute the probability of going up or going down. Instead, we say that you have sold an Acme option at a fair price, and you are going to purchase a fractional share of Acme as a hedge so that you will receive the same amount whether Acme shares go up or go down. A reminder of the situation. This diagram is turning into a bit of a disaster. Okay, either the shares go up to 48 or down to 16, and the strike price of the option is 24. Okay, let's think about what happens if the shares go up. You bought the shares at 20, so you made $28 per share. In other words, you make 28 times delta for delta shares. But you sold this option, you have to buy a share of Acme at $48 to give to the option holder, so you lose 24 on that transaction. If, on the other hand, Acme shares go down, you lose on your hedge. You lose $4 for each share, but the option became worthless, so you get to pocket what you received for selling it. Okay, we solve this equation. This turns into 32 delta equals 24, or delta equals 3/4 of a share. So owning 3/4 of a share is the perfect hedge after you've sold the option. Now let's figure out the fair price of the option. I'll use the name X for the fair price. And let's think through this transaction. You need to buy 3/4 of a share. That's going to cost you $15. And to raise that $15, you borrow not the whole $15, because you did actually sell the option for price X. You borrow 15 minus X dollars. Now what happens after 3 years? After 3 years, you sell the shares, you settle the option, and you pay off the loan. And the net effect of that is that you come up with $0. You break even. Strictly speaking, I can determine X by considering either case, but I'm going to do it both ways just to convince you that that's what happens. So let's first figure out what happens if the option is in the money. If the option is in the money, let's calculate the amount received. You receive $48 per share for 3/4 of a share. You pay out $24 to sell the option, and you pay the bank 6/5 times the amount you borrowed, and you should come out with a balance of 0. 36 minus 24 minus 18 plus 6/5 X equals 0. So 6/5 X equals, well, 36 down to 12 down to minus 6. 6/5 X equals 6. And what do you know? You also conclude that the fair price at which you should sell this option is $5. Interestingly, you've done that without ever explicitly considering the probability that the option will go up. A slightly simpler way of doing this is thinking about what happens if the option is not in the money. If the option's not in the money, you sell off the shares you bought. You only get $16 from them, but that's okay because you don't have to settle the option. You do, however, have to pay back the bank. And you break even on this whole transaction. In other words, you get 12 minus 18 plus 6/5 X is equal to 0, again concluding that X equals 5. So this is in its simplest form the Black-Scholes argument. Whether you figure out the fair price using probabilities from the buyer's point of view, or you figure out the fair price from the seller's point of view by designing a perfect hedge, in either case you get the same fair value. Now we're going to move on to the proof, which is basically a repeat of this same calculation algebra. So let's set up the general situation. Shares are fairly priced today at S, and in this wildly simplified model, there are only two possible values in the future. Either the price has increased by a factor of U, or it has been multiplied by a factor D that's less than 1, and it's gone down. If you put your money in the bank, it will grow from S to S e to the RT. And there's the strike price of the option, the price at which you can buy the share. The higher the strike price, of course, the less the option is worth. So now let's do the buyer's calculation. P is the probability of the higher price. And what do we mean when we say that S is the fair price? We mean that the probability of going up times the higher price, SU, plus the probability of going down times the lower price, SD, that's equal to the amount you'd end up with if you just put your money in the bank. S cancels out, and we see that P times U minus D plus D equals e to the RT. So we've got a formula for the probability that the price will go up. It's e to the RT minus D divided by U minus D. Okay, I'm going to call the fair price of the option, and the subscript B is for buyer. What makes this the fair price? Well, the probability the option will go up is P. Sorry, the probability that the share will go up is P. And in that case, as the option holder, you gain S times U minus K. The price is fair if you would have ended up with the same amount by not buying the option and just putting your money in the bank. In other words, F sub B is equal to e to the minus RT times the probability P, for which we had the formula e to the RT minus D over U minus D, and that has to be multiplied by SU minus K. I can simplify this a bit by multiplying these two factors together, and my conclusion is that from the buyer's point of view, the fair price of the option is SU minus K over U minus D times 1 minus D e to the minus RT. Now let's do the same analysis from the seller's point of view. What the seller does is to buy delta shares as a hedge. And let's repeat that calculation. We say this is a perfect hedge if what you receive if the shares go up is the same as what you receive if the shares go down. If the shares go up, you've got delta shares and you sell them at the higher price SU. However, you have to pay off the person that bought the option from you. You have to pay that person the share price minus the strike price. If the shares go down, you have delta shares that you sell at the lower price SD. This is an equation that we can solve for delta. I get delta S times U minus D is equal to SU minus K, and therefore the number of shares you want to hold as a hedge is SU minus K over S times U minus D. How do you buy these shares? Well, you borrow money from the bank. You need delta S in order to buy delta shares, but you got some of that money by selling the option at the fair price, which now I'm going to call F sub S. Okay. On the settlement date, you have to break even, and you can do the calculation either assuming that the price went up or the price went down because you have a perfect hedge. The calculation is almost invariably easier if you assume that the price went down. So what happens if the price went down? Well, you take your delta shares and you sell them for this diminished price, S times D. You also pay off the bank. So you borrowed delta S minus the fair price, and you pay that back with interest. In other words, you multiply it by e to the RT, and the net effect of this is you break even. In other words, Fs times e to the RT, this term, moving it over to the other side, is going to equal delta S times e to the RT minus delta S times D. And we're almost done. That means that according to this analysis, the fair price is e to the minus RT times this, which is delta S times e to the RT minus D. But we know what delta is. There's our formula for delta. And if I multiply it by S, I just get the S removed from the denominator. So I get SU minus K over U minus D, multiplying this factor by that factor. I get 1 minus D e to the minus RT, which is exactly the same result. And that is the essence of the Black-Scholes analysis.